Mr. Abbott here, and time for another boring science explanation. This time we're looking at number 59 from the boring diagram explanations. Essentially, these diagrams can help us discuss both groundwater zones and infiltration factors, definitely from topic 8. So the top model shows you precipitation. I labeled that falling onto the Earth's surface. The model shows that one of the things that can happen is the water can actually seep into and move below the surface. When that happens, it becomes groundwater, and if gravity pulls it far enough, the groundwater can, infiltrate all the way down and become part of zone B once it reaches the water table. But one question we might ask is, what can happen to that infiltration when it happens to hit the surface? Does it have to infiltrate? Well, when we look at infiltration means the water seeps into the surface. For the water to actually be able to flow into and below the surface, there are two characteristics that must be true. The first thing is the surface must be permeable. A permeable material will allow water to flow through it. If you have a goalie, you don't want your goalie to be permeable. You'd prefer to have an impermeable goalie. The second thing is the surface must be unsaturated. If the surface were already filled with water, there'd be no room for the water to infiltrate, so it couldn't go in. So the first thing that might happen, and it's good if water infiltrates and becomes part of the groundwater system. Now, if it can't flow in, another thing that happens is the water could run off. Okay, runoff would mean instead of infiltrating, the runoff would flow across the surface. Where is that runoff going to collect? It's going to collect into streams and rivers and lakes. Eventually, all the water makes its way back to the ocean because of the water cycle. But when you look at runoff, as water flows across the surface, it will increase the level of water in the streams. Usually that's described as the stream discharge or the stream volume. Now, another process that can happen, instead of getting infiltration or runoff, some of that moisture, and it's shown here by the plants, some of that moisture could actually go back into the atmosphere as water vapor again. So if it's warm enough, if it's windy, some of the water might evaporate. If there are plants in the area, some of the water that fell as precipitation could transpire back into the atmosphere. Now, the last thing is what might happen if it's really cold. Not all precipitation falls as water. Water can infiltrate into the soil, but ice and snow can't. So if it's a cold enough time of year or you live in a cold enough climate, one thing that could happen, or the last thing that can happen here, is the precipitation could be stored as ice and snow. Okay? At the poles, it might be stored for hundreds of thousands of years. But usually, for us, the moisture, the snow, the ice is going to melt frequently in the spring. That's one of the reasons why you have the highest level waters, the highest stream discharge in the spring. So it's going to be temporarily stored as snow and ice. Okay, eventually it will melt when the temperatures rise above the freezing point. Then the water is either going to infiltrate or run off or evaporate or one of the other processes. Now, looking at our top model, okay, there are two distinct zones. Zone B on the bottom is called the zone of saturation. When you look at the zone of saturation, the characteristics, if you could look in between the particles in the zone of saturation, the pores, the spaces would be filled with water. So every single little space between the soil particles is completely filled, it's saturated. The area above it is called the zone of saturation. Within the zone of saturation, the pores contain air and water unless everything is evapotranspired. In the middle of a drought, your zone of saturation could be completely dry because that moisture clinging to the soil particles could evaporate back into the atmosphere. Now, they have listed the top of the zone of saturation as the water table. The water table is the boundary that separates the two zones. And it's not a fixed boundary. Okay, if you get more infiltration, then more water is going to flow down into the zone of saturation and your water table could rise. When we get less rainfall and it gets drier and hotter and you get more evapotranspiration, the water table can fall. We could even start pumping out groundwater like they do frequently, and that's going to lower the water table. So if we drill wells below the surface of the water table, and we have a well where water is being pumped out for us to use, that's going to drop the level of the water table surrounding it, and the groundwater is going to continue to flow into the well until the wells eventually, honestly, could become dry if we overpump our groundwater resources. All right. The second thing we consider using these diagrams is we could look at the factors that determine whether we get infiltration or runoff, or the factors that control or influence infiltration. Now, the most obvious thing for these factors is what the surface is. So you have to look at the type of surface. If you have loose soil and loose sediment, they tend to allow more moisture to flow in. Long Island has nice sandy soils, so almost 50% of the rain that falls on Long Island infiltrates into the groundwater system. Since that's where we get our water from, that's, wonderful that our soils are so permeable. Other places with solid, continuous, unbroken rock, the water just can't infiltrate. So if we're looking at the type of surface, you could say for infiltration, which is usually a positive, the surface must be permeable and unsaturated. Okay, if they describe a surface as impermeable, that means that water can't flow through. And there are certain natural materials like bedrock where it's so solid and continuous that you get an impermeable surface. Now, if you've, been at a location where there's changes in topography, one obvious thing that is going to affect whether the water goes in or runs across the surface is the slope of the land. Okay, if you tend to live in an area where there's steep slopes, that's going to significantly increase the amount of runoff. So you're going to get more runoff where you've got really high gradient or a high slope. When you have a gentle or gradual slope, that allows the water more time to actually infiltrate, and a nice flat area, you're going to have more infiltration. All right, now the second diagram that we drew up here actually shows something that people can do to control or help, increase the amount of infiltration. All right, one thing that we can do to change the amount of infiltration is to plant vegetation or to increase the ground cover. Okay. If you have a barren field, very little water is able to infiltrate. So when you add plants, if I add plants, adding plants will slow down the precipitation and allow more infiltration. If you look at our two soils, Field A and Field B have the exact same slope. It's the exact same type of soils, but this one has grass and humus, which is broken down organic matter, okay? And you're seeing that you're getting a much deeper wet zone where the plants are slowing down the rain and allowing it to infiltrate. Over here where you have bare soil, even though it's the same slope, you've got a much shallower wet zone. So less moisture is going into the soil, which means you've got more runoff. So if you have bare soils without vegetation, you're going to get more runoff. Now, we'll see that's going to lead to more erosion. So frequently people will just plant something. They'll put some ground cover down to make sure that the soil isn't worn away. Obviously, you should describe the saturation of the surface. Okay, there's only so much space, there's only so many pores in between the soil particles. You can't add an unlimited amount of water. Eventually those pores, those spaces get filled. So if a surface is saturated, that means all the pores are filled. Then runoff occurs. How fast it rains can control a little bit about how much gets in. If you have a heavy rain, if it's coming down in, buckets, you wind up getting more runoff. If it's a light, gentle rain, then you tend to get more infiltration. Now, one last thing we could say is the temperature can play a role, because the temp has to be greater than 0 degrees Celsius for infiltration. If it's not liquid water, it's not going to infiltrate. So there's 6 things that can change or influence how much runoff or infiltration you get. There's essentially 4 things that are going to occur when rain hits or strikes a surface. I hope that helps you understand these 2 diagrams and you see that, infiltration is an important process. Take care.